Hello everyone, my name is Laukumar Echan, Department of IAC, Sri Venkateshwara College of Engineering, Bengaluru. Today I'm going to explain about RSA algorithm. So this algorithm mainly comes under the topic or subject called cybersecurity or cryptography. So it's a basically related to encryption and decryption. So let's see what is encryption, what is decryption, and what is this RSA algorithm step by step. First, in this RSA algorithm, uh, we need to generate a key. So that key generation is a crucial step in the RSA algorithm. It involves selecting two large prime numbers, calculating their product, and finding two additional numbers that satisfy certain mathematical conditions. These numbers from the public and private keys used for encryption and decryption. So here, majorly or like not majorly, we need to consider prime numbers, and after considering we consider two prime numbers like p and q, and we will get we will calculate their product, and so we will find the two additional numbers where they satisfy some mathematical conditions. In few further slides I will show those mathematical conditions. So these numbers and these numbers form a public and private keys used for encryption and decryption, where public key means every both sender and receiver will know that, but the private key, where sender will create a private key and he will send to the receiver, and the receiver, by using that private key, he will decrypt the message or whatever information sent by the sender. Now let's see how encryption will happen. So this encryption is the process of converting plain text into ciphertext using the public key. The ciphertext can only be decrypted using the corresponding private key. So already I told how this uh, public key private key works. So this RSA algorithm uses modular exploitation to perform encryption. So this specifically this RSA algorithm uses this modular exponentiation. So this concept or this method is used by this RSA, and also um, we need to look into the decryption part also. So this decryption is the process of converting cipher text back into plain text using the private key. The RSA algorithm uses modular exponentiation to perform decryption. Only the holder of the private key can decrypt the ciphertext. So in simple, if you want to know about this, what is ciphertext, all those things, I have done a video. I will try to add it in end cards, so you can go there and you can check out that video also. So basically this encryption and decryption is mainly used to secure our information. For example, the companies where they are having a very crucial or very important data, they need to maintain the data safely. So the data is a major thing in current world. So in order to have a better security for that data, so there are many people who are working in every company to maintain data securely. So that process basically happens from one person will maintain that data securely by using a private key. And if you want to send that data for someone who is not who will not affect that data, for that person he will send that data in the form of ciphertext, actual text into ciphertext he will convert, and he send that ciphertext, where the receiver need to convert that ciphertext into plain text. So in order to convert that, he will fetch private key, or he know how to decode that, and he will decode that, and he will I, identify the private key, and he will get that information. So the this process is both for both sender and receiver, they come to know what to do and how to do. So that's how this encryption decryption works. Now let's see algorithm. So in first slide I told about a key generation. So first we need to select of primes. Choose two large prime numbers p and q. So already I told that we need to choose two prime numbers, like one is p and another one is q. Now we need to compute n, like where we need to calculate n. So n equal to p times of q. This is the formula. So now compute phi of n. After that, compute Euler's Taussian function, that is phi of n equal to p minus 1 times of q minus 1. we need to consider public key where e dot n select public component e such that 1 less than e less than phi of n and text gcd of e phi of n equal to 1. Private key d comma d and n where calculate the private component d as the modular multiplicative inverse of v modular and like this here d equivalent e power so minus 1 mod phi of n. So first we need to take two large prime numbers, that is p and q. After that, in order to satisfy these conditions, we need to choose the numbers, that is e and d. So by using this like p and q prime numbers, also these e and d, we will compute pi of n and the value of n. So all this we will calculate. So this is the uh, one process of algorithm, and also after that process we will do encryption. So and sender obtains the recipient's public key. So if I am a sender, I will get the um, recipient's public key. I mean the who is the person who is going to receive from other end. So I will get his public key, that is e and n. After that we will represent the plain text message as an integer m in the range 0 to n, 0 less than m less than n. This is the order. After that, we will compute the ciphertext using the encryption formula, that is c equivalent m power e mod n. This is the formula to compute the ciphertext, and we will transmit c to the recipient. So this is how the encryption will happen. First we will take the recipient's public key. After that we will represent that plain text message as an integer, and also we will compute that ciphertext using the encryption formula. We will having a encryption formula. Using that formula, we will compute the ciphertext and we will transmit to the recipient. After that, we will transmit that to recipient. Now how the recipient will do the decryption? So recipient uses their private key, so he will decode that ciphertext, and he will use their he will using that private key, he will decrypt that, and he will compute the original message using the decryption formula. He will be having a one formula how the encryption, the person, the sender had a one, sender is having one formula. Also in same way that the person recipient also follows a different formula to get that information. This is how the decryption will happen. Now let's see, the security of RSA is based on the difficulty of factoring the product n into its prime factors p and q. So also known as the RSA problem. Breaking RSA encryption would require factoring a large composite number, which becomes computationally infeasible with sufficiently large prime numbers. So this is how this RSA algorithm, and RSA means there are three scientists who discovered this algorithm. So they are their first letters like R. R means one scientist name, and S means Sheldman, and A means Aldman. So these are three scientists. Their first letters taken, and they formed this algorithm. They named this algorithm as RSA algorithm. And we need to look into some key points here. The public key is used for encryption, while the private key is used for decryption. So already we know as public keys e dot n, and it is used for encryption. D dot n is used, d comma n is used for the decryption. The security of RSA relies on the difficulty on factoring the product of two large prime numbers. So that is, we need to consider two large prime numbers p and q. RSA can be used for secure key exchange and digital signatures in addition to encryption. So in for we can RSA can also be used for secure key exchange and for digital signatures in addition to encryption. So here also this RSA can be used. Now let's see the security considerations where we need to what we need to consider, what we should not forget to consider. First, we need to consider two large prime numbers that already I am telling that from beginning of my video. That mainly because to avoid to prevent factorization attacks, the RSA algorithm relies on the use of large prime numbers, and we need to consider a secure private key. Keeping the private key secure is crucial for maintaining the security of the RSA algorithm. If we make some changes, if we can't get a proper private key, then there is no use of doing that also. So that's why we need to keep a proper private key in order to secure the information. And vulnerability to timing attacks. The RSA algorithm is vulnerable to timing attacks, which can exploit variations in the time taken to perform cryptographic operation. So we are listening this term like a cryptocurrency, like probably many people may heard about this term cryptocurrency. So basically this cryptocurrency all happens with these encryptions and decryptions and also on different technology called blockchain. So here are they in the cryptocurrency part also this RSA algorithm plays a major role. And also we need to consider some additional security measures like padding and randomizations. These can be used to enhance this RSA algorithm. So we need to look about this padding and randomization. So these are some two terms. So in addition to we need to consider. So these are some security considerations when it comes to the RSA algorithm. Let's see the applications. Mm, so what is the application of RSA algorithm means as of now we can tell that we use that RSA algorithm for the security purpose. Everyone will tell that. In that is damn sure that like everyone is there, it's secure communications. So this is one of the main application of this RSA algorithm where it secures communication over the internet. It is used to encrypt and decrypt sensitive information, ensuring that only the intended recipient can. So if we take real-time examples like the HL in Bangalore, HL, it's a government where uh, they manufacture like Indian aircrafts or some uh, war equipment, so where they are very important for the our Indian army. So at that in those locations, the these communication should be happen by using this cryptography. So they should maintain a proper cyber security or cryptography people. And also in digital signatures we can use this RSA. So this is you which also provide authentication and integrity verification for electronic documents. Digital signatures are widely used in e-commerce, online transactions, and other digital communication. So, as of now, the online transaction is happening in our India is majorly the one of the major transaction is online and also e-commerce. Many people are using e-commerce also. So, in these conditions, this the RSA algorithm is widely used and very applicable. And also secure storage. The RSA algorithm is employed for secure storage of sensitive information. So same. So if you want to store, if you want to keep private, we need to maintain a data which is very crucial for our needs or for our country, for our state. Those condition, those type of informations can be stored with very secure form. And also wide range of industries. This RS algorithm widely used in various industries, including finance, healthcare, and government sectors. So government sectors means like um, these industries were mainly funded by our Indian government or so the government like HL, maybe ISRO. So these kind of government sectors. Also healthcare means in hospitals are related to some diseases. Their vaccinations, all those things of pharmacy. So in those situations, in order to maintain their formulas safe, we use this RS algorithms. And like in finance also, so we need to banking in banks, we need to have a proper security if because there are many people will be believing will be trusted by the that bank. So like that in wide range this advantage of industries, this RS algorithm will be used. So that's all for today. Now, I hope you liked. If you have watched my video till now, I hope you liked video. If you really like the video, please do like my video and share with your friends. For maximum people, you try to share it because it's very crucial for our college assignment part. We need to get minimum views and minimum likes. So please do that for my sake. And once again, thank you.